It's a pleasure being back in Chautauqua Lake. I gave a talk here a couple of years ago, and periodically over the last 28 years or so that I've been working for the state. It's always a pleasure coming back here, even when I get lost on my way here, which is probably half of the time. So that's the problem of trusting an Eastern New Yorker to figuring out how to get through Western New York. It can be a challenge sometimes. As Jane said, I'm going to talk a little bit about a couple of topics that have already been addressed, and I want to try to bring them home. So you'll hear some of the same points tonight that you heard John Titus and others give a little bit earlier, I expect. But I hope it'll be a little bit of a different twist. There have also been a number of talks in this area from other experts on harmful algal blooms like Dr. Greg Boyer, and I'll cover some of the topics that he covered as well. So I apologize in advance for any redundancy. Some of you may also be aware of the topic of harmful algal blooms and Chautauqua Lake because of an article that appeared in The Conservationist that I wrote. And I don't know how many of you have read it, but for those who haven't, I'll say what the article should have been, what I intended it to be, which was a love story. A love story in The Conservationist. You can see why it didn't quite come out as a love story. But it was intended to be a story of the love of New York that New Yorkers have for their lakes. And I don't know of a better example than Jane and Doug, who have dedicated so much of their time, so much of their lives to Chautauqua Lake and to the protection and improvement of Chautauqua Lake. And I tried to convey some of that in the article, and I'll try to convey some of that tonight. But if this talk were being given about Chautauqua Lake, another part of the state, I would have to spend some time talking about how this community loves this lake. So I won't worry with that. You all know that. You're among those that love this lake. So what I'll try to do is focus on some of the reasons why we're concerned about problems that are occurring in the lake and some things that you can do to help address some of those problems. Whenever I give talks about lakes, it can be about a wide variety of topics. Increasingly, these are the two that seem to occupy an awful lot of our attention and an awful lot of our talking. Harmful algal blooms on the left. This is not Chautauqua Lake, but it's a lake like Chautauqua that regularly experiences harmful algal blooms, and invasive species. I'm going to talk about both of them tonight, and I'm going to talk about how they're connected together and the kind of things that people can do to help prevent recurrences of these things and the next generation of these things. So, what I'm going to talk about over the next hour, HABs, harmful algal blooms. I'll focus on that in the beginning. Then I'm going to talk about invasive species. I'm going to talk about how they're connected to each other, and I'm going to talk about what you can do. I have a tendency to wander in my talk, so I'm going to cover each of these points at various times during the talk. So that's, in theory, the order. I may go off script a couple times, so again, I'll apologize in advance for that. So let's start with harmful algal blooms. You may have heard the term. Again, a recent article in The Conservationist about harmful algal blooms generally and Chautauqua Lake specifically. And I think for those not really familiar with the topic, it's really worth breaking down those terms. Harmful, algal, and bloom. I'm going to start with the one in the middle, algal, because right up front, we're not being entirely honest when we use the term harmful algal blooms, because what we're talking about here is not really algae. It looks like algae, it behaves like algae, and for many years it was referred to as algae, but actually it's not. It's a bacteria, specifically a bacteria called cyanobacteria. Cyano being blue-green, and therefore we're talking about a blue-green bacteria. It photosynthesizes like algae does, so it can grow and reproduce through the actions of sunlight and the production of photosynthetic materials, but it is not an algae. The harmful and the bloom are really important, and I'll touch on the bloom part first. Cyanobacteria, blue-green algae, are found in every water body in the state, from Lake George to a tiny pond in your backyard and everything in between. You're going to find cyanobacteria or blue-green algae every time you look for it. The difference is, in some cases, you see so much of it, it's what we refer to as a bloom, an overabundance of algae. So much of it is growing that it can create a significant problem, a dense concentration. Those are the ones we're concerned about. So you may hear that someone collected a water sample and they saw blue-green algae in it. Oh my God. That shouldn't be the reaction. Blue-green algae are commonly found. They're natural. They're found in all water bodies. What we're concerned about is a bloom. So much of it that it creates a problem. And that problem is the first part of this term, the harmful part. Cyanobacteria, blue-green algae, can produce toxins. They can produce liver toxins and they can produce nerve toxins. We're concerned about both of those. They can create harmful conditions for people using the water, for the ecology within the lake, and it can impact a variety of uses of the water. And I'll spend the next couple minutes talking about that. So, I'm not going to go into a lot of the details about the toxins, but there's a few things to know. And I'm going to go over some of the specific ones in a few minutes. There's a wide variety of toxins that we believe are being produced. Most of them are produced in very low quantities, so low that we can't really detect them. But some analysis indicates they're there at such a low level that they really don't create a problem for people. They're produced within the cells themselves, but when the algae cells break down, and that can happen from a variety of ways, they can die off naturally, they can be induced by things like copper sulfate, they can be consumed by organisms, and when that happens, the toxins can actually spill out of the cells. Several different varieties of blue-green algae produce toxins, but those species don't always produce them. They have what you can think of as an on-off switch. And we don't know why that on-off switch occurs. It happens in some water bodies and not others. It happens in some circumstances and not others. We're trying to learn more about that, but that on-off switch is very difficult to understand and even harder to predict. So the toxins that we're concerned about, I'll mention the two that are our primary concern. Something called microcystin. It's a liver toxin that can be produced by blue-green algae. It is by far the most common one that we see in New York State, and it's produced by a variety of blue-green algae species. The other one that we're concerned about is a nerve toxin called anatoxin, specifically anatoxin A, and there's another variant called anatoxin AS. That's also produced by a wide variety of blue-green algae. And it is commonly referred to, unfortunately, as the dog-killing toxin, because it's a nerve toxin that acts very quickly, and in some cases it can create problems. There have been a number of dog deaths in New York State that have been attributed to this particular toxin. Very difficult to detect, not very commonly found, therefore, but we believe that it is affecting dogs in many ways. Then there's a third class of toxins that's worth thinking about, what's referred to as an endotoxin, those that affect the skin. Think of it like poison ivy. Some people are not susceptible to it at all. Some people are extraordinarily sensitive to it. Specifically, it's an organic compound called a lipopolysaccharide that's produced by these blue-green algae species. That's an endotoxin that creates a toxic reaction on the skin. Again, just like poison ivy creates that toxin reaction. So those are the three large groups: nerve toxins, liver toxins, skin toxins that we're most concerned about. There are a number of other toxins that usually fit into one of those categories, and I have them listed below. I'm just going to mention the two that are on the bottom there. Lingzhi toxin. Most of what we're talking about here are algae that are within the water themselves. You grab a bottle of water and you'll encapsulate those algae cells. The things that either cause a scum on the surface or greenness within the water. But there are some toxins that actually can be found in the algae that grow on the bottom of the lake. There's lots of forms of algae called benthic algae that grow on the bottom of the lake, and almost all of those are not toxin producing. But there are some very difficult to detect, very difficult to sample for, but we do see them, Lingzhi toxins, and they can create primarily they're endotoxins. They create dermal reactions. So we'll get reports every so often of dogs that have rashes on their paws because of their exposure to Lingzhi toxins. The other one, BMAA, you may have read about. If you do an internet search on cyanobacteria, at some point you're going to encounter this term. It is the precursor to ALS, Lou Gehrig's disease. There is some research suggesting that blue-green algae production can actually trigger the production of BMAA. We have never seen that in North America. We continue to analyze for it. Dr. Greg Boyer, who again spoke in this area, I think about a month ago, has analyzed more than 5,000 samples in New York State. He hasn't detected it in any one of them. We have not seen this in North America as best as we know, but it has been found in other parts of the world. So a whole class of toxins, the vast majority of them not found in New York State or not found at levels that we need to be concerned about, but the three major categories, liver toxins, nerve toxins, skin toxins, are the ones that we're primarily concerned about. So why are we concerned about them? Well, because they are multiple routes of exposure for people. The two major pathways that these toxins can get into the body is consuming water, and I put that term in quote because in some cases we're concerned about the actual consumption, drinking the water purposefully, drinking the water that may have toxins in it. But consumption also refers to incidental consumption. You're out swimming, you occasionally swallow a little bit of water. That can be a route of exposure as well. And then the other class is general contact recreation. Again, the skin toxins are the ones where if you're regularly exposed to these toxins, for some people, not all people, probably not most people, that skin reaction can create, that skin exposure can create reactions. If you look at the symptoms that are associated with blue-green algae exposure, stomach upset, pain, vomiting, headache, fever, things like that, probably sounds an awful lot like the common cold or fever or food poisoning or all of those kind of things that people get during the summer. So we expect that the incidence of blue-green algae exposure and symptoms associated with that are tremendously underreported. There aren't very many cases in New York State, probably just a handful that are connected to blue-green algae each year. There are some, not many. We suspect it's a lot more common because by the time many people see these reactions, it's occurred after a long day out in the sun. Maybe they've eaten things out in the sun and they naturally say, well, it was probably something I ate. They don't connect the dots, so to speak. In some cases, it's not appropriate to do that, but it's important to know that many of the same symptoms associated with blue-green algae exposure are commonly found with other ailments that occur during the summer. So, a really short history of harmful algal blooms in New York State. Oneida Lake is where we have a long documented history of it, going all the way back to 400 years ago when Samuel Champlain, in the process of exploring the area, including Oneida Lake, reported out conditions that we now would call an algae bloom. 200 years later, or about 200 years ago, James Fenimore Cooper termed what he saw on Oneida Lake, lake blossoms. And if you think about that, it's a blossoming of a plant. That's what an algae bloom effectively is. Even 200 years ago, there was some description in the literature of what we now refer to as algae blooms. If you go back almost 100 years ago, it was the start of the old DEC, the old State Conservation Department, which was the predecessor to my agency, the DEC, that did a biological survey of all of the 17 major drainage basins in the state. They looked at a couple of hundred water bodies, and they looked at plants, they looked at animals, they looked at water quality, and in several of those, they reported blooms almost 100 years ago. We'll talk a little bit more about where Chautauqua fits into this as well. So that was 400 years ago, 200 years ago, almost 100 years ago. Fast forward to what I'm referring to as yesterday, really just the last couple years. We first became aware of this issue as a significant statewide problem, largely because of outbreaks that occurred in some of the very large water bodies in the state. Lake Erie, Lake Ontario, Lake Champlain had regular bloom occurrences. And some of these continue to bloom at least occasionally. Many of you no doubt are aware of what happened in Toledo, Ohio about 2 or 3 weeks ago, and a significant algal bloom in the western basin of Lake Erie. So these things continue to go on today. What really drove it home, however, was a couple of smaller water bodies, still fairly good-sized lakes, but smaller than Chautauqua Lake, for example, where repeated blooms on Sodus Bay, on Honeoye Lake, other places caused regular beach closures and regular incidences where the public said, DEC, Health Department, what are you guys doing about this? And it prompted us to start to do something about it. Fast forward to last year. The National Wildlife Federation did a survey of as many states as possible, turns out to be 21 of them around the country, where there was some level of harmful algal bloom documentation. They asked managers in each one of those states, me, the health department, and our equivalents in 20 other states around the country, how significant a problem is it? How many reports of these blooms do you have? The most any state had documented in 2013 was 12, except for New York. At the time of this report, which was in September, we had documented 50 separate water bodies in the state that had harmful algal blooms. And actually, before the end of the year, that number was up to 62 places around the state. Kansas second with 12, New York first, 62. Big difference. Is it a worse problem here, or are we documenting it better? We'll talk about that in a couple minutes. So, the documenting, to some extent, gets at who does what in New York State. And New York, like many other states, has a tapestry, quilt work, collage, confusion of how we do water quality monitoring and documenting conditions. There are 3 agencies at a statewide level that are responsible for understanding this issue. The State Health Department, which was the one that first took up this mantle and received a Center for Disease Control grant about 6 years ago to study this in more detail. They have a policy for beaches. Most of the beaches of the state are regulated by the State Health Department, and they have a formal policy that says, if you see green water, close the beach. We'll do monitoring after that, and I'll tell you in a couple minutes why there's some lag in monitoring versus a decision about beach closures. State Parks and Recreation, which has a site here on Chautauqua Lake, also largely follows the same protocol. They use visual evidence to say whether or not conditions are consistent with what appears to be a blue-green algae bloom, and will make a determination for closing a beach based on what they're seeing visually. So again, for both agencies, visual is the primary means for making a decision with some monitoring. DEC, on the other hand, really has responsibility everywhere else. We don't regulate beaches, that's the Health Department. We don't regulate state park water bodies, that's Parks and Recreation. We do regulate a few beaches within the Adirondacks. There are a couple of state parks that are administered by DEC, but really our responsibility is everywhere else. And the everywhere else is largely a notification responsibility. If you have a bloom outside of your dock, I cannot tell you you can't swim there. We don't have that authority. DEC is not given the authority to close your beach area, your dock. The Health Department can close a beach. Parks and Recreation can close a beach. In the Adirondacks, we can close a beach. Everywhere else, that authority is not vested within the agency, so we can't shut down a water body. What we do is primarily provide advisory information to people. We gather as much information as we can. We try to document where blooms are occurring, and I'll tell you in a couple minutes how we do that process. But our role is primarily advisory. We try to tell people, here is the information you need to know about your water body, and it's an opportunity for you to make an informed decision. If you elect to swim in green, scummy, awful-looking water, that's your call. We just want to make sure you have the right information so that you know about the risks associated with doing that. So we work with the Health Department, Parks and Recreation, SUNY ESF that does monitoring in our program, SUNY Stony Brook, which does monitoring in Long Island, and a variety of other partners. But even when you add up all of those entities, academic, some local government, local health departments, state parks and recreation, park managers, DEC, sounds like a lot of players, but there are somewhere between 7,000 and 20,000 water bodies in New York State. We simply don't have the resources, the bodies, the eyes on the ground to really understand what's going on in most of those water bodies most of the time. Because of that, we rely heavily on citizenry, people telling us what they're seeing, sending us pictures, in many cases collecting samples. So one of the reasons we have documented more blooms than almost every other state is because we have a very robust monitoring program. So I'm not going to go into a lot of the details about this, but we've gone through a long process of trying to understand what information do we want to collect. How do we want to document it? What does that tell us about a water body? Most of the monitoring that we do focus on what's going on in the center of the lake to understand what could be going on in a lot of places where we can't see, and where reported to us is a shoreline concentration of algae, a bloom in which we sample, in most cases, the most dense part of that bloom. We want to understand what's the worst case conditions, so that if that's okay, then we're pretty comfortable in saying there doesn't seem to be much of a risk. If that's bad, then it's telling us it's likely that there is a risk associated with swimming in that water body. So, the primary means that we have for gathering that information around the state is a mechanism that's in place right here in Chautauqua Lake and in about 120 other locations around the state. It's CSLAP, the Citizen Statewide Lake Assessment Program. Jane mentioned it a little bit, and I'll just go through a couple of the key highlights. It's a program DEC runs jointly with the New York State Federation of Lake Associations, for which Chautauqua Lake has been a long-standing 25-plus year member. We initiated it almost 30 years ago, initially with 25 lakes in the program and about 150 sampling volunteers, largely distributed around the state. By year 2 of the program, 1987 effectively, Chautauqua Lake joined that program and has been actively participating since then. Jane and Doug and a small number of other volunteers have been doing work for nearly 30 years in this program to understand water quality conditions, to document them, and to identify where blooms are occurring. We'll talk more about that in a couple of minutes. It's a joint DEC Federation of Lake Associations program, and on the bottom, it's worth noting here that as of 1988, state law was rewritten to mandate that we run this program because it's very cost effective. We use the information for an awful lot of purposes, and it's nice to have a hook in state law that says when budget times are a little bit bad, we're going to keep running the program. So we've run this continuously for 28 years. I've run it continuously. I was hired to run the program almost 29 years ago and have done it since then. In that time frame, we've collected more than 25,000 samples from 240 lakes around the state. Nearly 2,000 volunteers have been involved in the program. And at any one time this year, about half that number, 120 lakes, are actually sampled as part of the program. A lot more details about the program. I won't bore you with the specifics, but generally it's a mix of state funding and private funding that helps support the work that's done on the program. One of the reasons that we feel so passionately about this program is the power of volunteers. I can go out and collect water samples in a lake, and we have our own program in which we do that. We go to different regions of the state and we collect a lot of water samples. At best, we can get out to a water body maybe about once a month. An awful lot can happen in the 30 or so days between the time we're out there and the next time we're out there. We don't live on the lake. We don't know what's going on. We don't see what happens on a daily basis. The people who are volunteers as part of this program do. They know what goes on. They know it's normal in the lake, and they know what's not normal. And they can call us and say, something's going on here. I think we're going to collect a sample to document that, to verify it. The power of volunteers. And I can't overstate that enough. It provides more than just an extension of DEC's monitoring arm. It gets a lot of information that we can't possibly get in our programs, and we use the data for lots and lots of purposes. So I'm also not going to go into a lot of details that are embedded in this table, but we have multiple levels of HABs surveillance in our monitoring programs. I mentioned State Health Department, Parks and Recreation have largely a visual monitoring program. We have DEC focuses in part on visual monitoring. We ask that pictures be collected as often as possible, but we want samples. We want to be able to document many of these blooms, and we document them in a bunch of different ways. We have samples looked at under a microscope to see what kind of algae are growing in there, or in this case, what kind of blue-green algae or cyanobacteria might be growing in there. There are some analytical tests that tell us how much algae is growing in there. And then there's toxin tests to tell us how dangerous that bloom may be. So the combination of all of those things makes up DEC's harmful algal bloom monitoring program. Mix of public and private monitoring, a mix of agency monitoring and Lake Association monitoring, and multiple agencies involved in it. All of those components exist here on Chautauqua Lake. So the volunteer monitoring program, Jane, Doug, Jeff Moore on the South Basin, continually collecting samples every other week during the summer. When blooms pop up, they collect samples. Chautauqua Institution has, over the last 2 years, been much more actively engaged in harmful algal bloom monitoring in a bunch of different locations on a weekly basis. So really extensive monitoring to understand what might be going on there in a direct, partnership with SUNY ESF. And then the county health department is actively engaged in making decisions about the beaches, in part from the information collected through these other monitoring programs, and in part through their own surveillance network. So a variety of visual and monitoring tools being used on Chautauqua Lake to understand where the blooms are. So we have all that data, and what we do is characterize blooms a bunch of different ways. For those places where we look at a picture and we say it looks like blue-green algae, but we're not sure, we call those suspicious blooms. So we might get pictures of this bubbling scum that might wash up on the shore. In almost all cases, that's not blue-green algae. And while it's ugly and it would be nice to be able to get rid of it, and many of the measures that are in place that I'll talk about a little bit later to try to reduce blue-green algae will also be effective at reducing these scums, we're not as concerned about those. They don't have toxins. They're much less of a health risk. They wouldn't fit the criteria of a suspicious bloom. But if it looks like spilled paint or pea soup or green streaks, or in some cases green dots, those are the typical characteristics of a blue-green bloom. And when we see those, we'll call those suspicious. In most cases, we'll try to get a sample from those. And if the sample documents in the laboratory that there's cyanobacteria in enough quantity that we can call it a bloom, then we're going to call that a confirmed bloom. In some cases, we're going to measure high toxicity levels in those, and we compare it to what the World Health Organization tells us is a high risk for swimmers. DEC does not have, and the New York State does not have, a water quality standard for toxins. We may, somewhere down the line. EPA does not have a national standard for toxins. They may over the next year or two. But until then, we will rely on the World Health Organization's criteria. But regardless of whether or not we see high toxins or high blue-green levels, or even if we can't get a sample and it just looks like blue-green algae, in all cases, we tell the public the following. Avoid exposure, because there can be some risk associated with that. Keep kids away from it, particularly. Keep pets away from it, particularly, because they are both based on their size and their willingness to roll around in it, they're more susceptible to blue-green algae exposure. If you get symptoms associated with it, the symptomology that I showed a couple slides ago, you should seek medical assistance because that could escalate into a more significant problem. Again, very few instances of that, in part because people look at that and say, ugh, I'm not going to swim in that. But sometimes kids do, and sometimes dogs do. And we occasionally get sent us a stark picture of this puddle of blue-green algae that has washed up, and you can see a kid playing in the sand right next to it. It scares you. So we know those things occur, and we again try to tell people seek assistance if you're seeing any kind of problems, and report those to the local health department. We want to document as many of these as possible, and report what you see to us. You might be through Jane, through Doug, through the Lake Association, through the Chautauqua Institution, through the county health department, but we want to know it and we want to document it. So we have been documenting it over the last couple years. As I mentioned before, it took the EC and the health department a couple years to really get fully engaged in this issue, but we're fully engaged in the issue now. The distribution on the left shows places around the state in 2011 where we had documented blooms. It was when we just got started in the process of trying to understand where blooms are occurring. In 2012, you can see that distribution changed a little bit. But there are a couple of hot spots, and I'm going to move over and show you a couple things here. So you see a cluster down here in what we call the lower Hudson Basin. An awful lot of lakes in this part of the state that have very high phosphorus concentrations, very high nitrogen concentrations, lots of algae, and lots of documented blooms. Western New York, sort of Finger Lakes on west, we see that in an increasing number of water bodies. And if we had as much data here as we have here, I would suspect we'd see even more dots, because an awful lot of lakes in western New York that we just don't have data on that we suspect have harmful algal blooms. And you got a big hole right here in the interior Adirondacks. We don't see harmful algal blooms everywhere in the state. And there's a couple reasons for that. In some places, like the Catskills, we just don't have very much data. We don't have very good monitoring programs for the Catskills. We do have very good monitoring programs in the Adirondacks, and we just don't see them there. And I can't remember if I'm going to show a slide for it, but within the interior Adirondacks, last year I think we had data from 60 different locations, and we saw one harmful algal bloom. You look in western New York, there are a dozen or so out of maybe 20 lakes that were sampled. A very high percentage of the time we see blue-green algae blooms out in western New York. Very little in the Adirondacks, and it's the key word, phosphorus. Phosphorus levels are much lower in the Adirondacks. So, 2013, when we became fully involved in our monitoring and outreach program. So, this is places where we've documented in New York State, and we're doing the same thing in 2014. So I mentioned 62 locations around the state where we confirmed a blue-green algae bloom was present out of about 170 water bodies that we had regular sampling data on. So about a third of all of the lakes that we sampled in the state had documented blooms. And again, you can see this big hole in the Adirondacks. Lots of data up here, we just don't see blooms. Many other parts of the state, much more extensive bloom occurrences. And the map that we show you here is, if you want to know where those are, you go to DEC's webpage. Every Friday, we update our webpage between middle of May and middle of November, where we have documented reports of blue-green algae blooms. You'll see a picture of New York State that shows a breakout of each of the major watersheds in the state, because there's lots of DEC watershed programs that you can find out about in part through this program. And we have a number on a map. That number corresponds to a table that's immediately below the map, and it says what we know about that bloom occurrence. Where it is, what county it was located in, was it one of our confirmed blooms or a suspicious bloom? How large was the bloom, if we know that information? When was the report of the bloom? In some cases, that might have been yesterday. In some cases, that might be 2 or 3 weeks ago. And what information was used to land this on the list in the first place. So this is updated every week during the summer. And tomorrow, I will be rushing back to the office to do the next upload of this. So I'm going to go through just a little bit of the data of what we've learned. As I mentioned before, we do sampling in a couple of different locations. We sample in what I'm referring to as the open water, near the center of the lake in the relatively deep water, which is the basis of most of our monitoring programs. We look not along the shoreline, but in the center of the lake. That tends to be most representative of most of the water of the lake. And I broke out one of the measures of blue-green algae, something called chlorophyll. It's a pigment that's found in all algae, and chlorophyll A specifically is a pigment that's associated with freshwater algae. Whenever chlorophyll A levels are more than 30 micrograms per liter, we call that a bloom. So you can see about 5% of the time, statewide basis, looking at 1,600 samples collected over a 3-year period of time, that's the frequency at which we saw blue-green algae blooms in the open water. So basically, shoreline to shoreline, top to bottom, extensive blue-green algae blooms. And only a very low percentage of those, about 2% of the time, did we measure toxins at a level that the World Health Organization would say that's at least a moderate risk for swimmers. Open water samples, center of the lake, not near the shoreline. Then you look at the shoreline, green is the color that we're concerned about, which is blue-green algae. Not green good environmental in this case, green bad, because it has high algae levels. About 60% of the time when people collect a sample along the shoreline that they think looks like blue-green algae, they're right. And it's at a high enough concentration that it's a blue-green algae bloom. Maybe just as importantly, nearly half of that time do we see high toxins in that. At least a moderate risk for swimmers, and in some cases a high risk for swimmers. And some water bodies are more susceptible to this than other water bodies. So, how susceptible is Chautauqua Lake? It's a lake that we've been trying to document blooms over a fairly long period of time. We measure a bunch of different things in our volunteer monitoring program. And as I mentioned, we've been doing this for a fairly long time in the lake. So, you look at a couple of measures here. Phosphorus concentrations. We believe that if phosphorus concentrations are above 20 micrograms per liter, it's susceptible to a bloom. Every year since 1990 that we've been sampling this lake, we've seen average phosphorus concentrations above that level. That suggests that the lake is susceptible. We define from an open water sample, anytime chlorophyll levels are above 10, That shows us that the lake is susceptible to shoreline blooms. And we measured that every year in Chautauqua Lake. I think this is all sampling from the North Basin. We also measured fairly low water clarity, and at times water clarity is low enough that it can actually create some problems for swimmers. So this data suggests that the lake is susceptible. What's the connection between algae levels that we measure in the open water and the production of toxins? Well, whenever toxin levels are above 1 microgram per liter in treated water, and that distinction is important, when it's above 1 microgram per liter in drinking water, the World Health Organization says that creates a risk for people drinking it on a long-term basis. Once you get chlorophyll levels above about 10 in the open water, it increases the likelihood. Still not a high risk, but increases the likelihood at which microcystin can be produced. Again, that's a sample in the center of the lake. It hasn't gone through water treatment yet, and that distinction is important. I'll talk about that in a couple minutes. Whenever microcystins are above 4, World Health Organization says that's more of an acute risk for swimmers. Right now, you should try to keep levels below 4 for swimmers. And once you get chlorophyll around 10 to 15 micrograms per liter, that's when we see a sharp rise in the frequency of how often a moderate risk for swimming susceptibility is. So 10 micrograms per liter in the open water seems to be the sweet spot, if you will. And I'm not going to talk about it here, but one of the things that DEC is in the long process of doing, like all of the other 50 states around the country, is we were charged, I'm embarrassed to say, in 1998 to develop water quality standards for phosphorus and for chlorophyll. There are, I believe, 2 or 3 states that have actually, in the 15 or so years since then, actually gone and put numbers on the books. Several of them are embroiled in lawsuits, either from industries, wastewater treatment industry, agricultural industry, or the environmental community. New York is sort of in the middle somewhere. But we're looking to set eventually a chlorophyll number of around 10, because that seems to be that trigger point by which algae production is so significant, so high that toxin production can be great. Lots of other reasons for it that I'm not going to go in here, but by several different measures of problems in lakes, 10 seems to be kind of that key number. So, where's Chautauqua Lake? Well, the North Basin is right about here. So, in the open water, not a real high susceptibility if the North Basin were typical of other lakes with about 20 micrograms per liter of chlorophyll. South Basin is quite a bit higher, and an increasing likelihood that you're going to see a risk for swimming. Ugh, data. Let me go through a couple of these things. The bottom one might be easier to at least visualize. Every time a water sample is collected, we have that submitted to SUNY ESF. They analyze it for a bunch of things. One of the things they look at is how much blue-green algae is in it and how much blue-green algae is in it relative to other forms of algae, like green algae or diatoms. When the plot shows blue, that's where we have blue-green algae. As the summer progresses, we see an increased likelihood here in the North Basin of the production of blue-green algae in the open water. So as the summer ramps up, you're more likely to see blue-green algae. Just about every time a shoreline bloom sample was collected, those were blue-green algae. South Basin largely shows the same thing. An increase during the summer. Levels are actually higher during the summer, and I'm not going to go in any real detail over the top 2 plots because I'll talk about that in a little bit. One of the other questions that we're continuing to ask is how long do the toxins last? So if an algae bloom produces toxins and then the algae die, do the toxins go away with them? In some cases, yes. So in the case of Pier Beach, for example, which was monitored over 2013, we saw blue-green algae drop off at the exact same time the algae dropped off. At this site, it mirrored it very closely. In some sites, like this one, we never detected any toxins. And at the other site, we detected some very high algae levels, but we never detected toxins either. It's complicated. We still don't really understand why they're being produced in some cases, why they're not being produced in other cases. So one of the other questions that we're getting asked, and we've been increasingly asked as harmful algal bloom information is making it more in the news, is it worse in 2014? So the plot on the upper left shows the number of statewide reports of blue-green algae blooms in 2012, which is in gray, 2013, which is in orange, and 2014, which is in blue. And both 2013 and 2014, we've seen more reports than we did in 2012. Is that because there's more blooms, or are people reporting them more? We just don't know. There are some lakes, Chautauqua may have been one of those, where at least in the first part of the year, we didn't see as many blooms in 2014 as we did in 2013. The lakes looked a little bit better. That was the case with several of the persistently blooming lakes in the state. And I will say that the 2014 numbers so far have been very heavily skewed toward New York City. We've been getting a lot of reports of blooms in New York City and in Long Island this year. And in the rest of the state, which I'll show in a minute, we haven't seen that same frequency of reports. High toxin levels, it's right around middle of July when we start to see the toxicity of these blooms increase, which is around the same time of the year that we're more likely to see blue-green algae production increase. If you look in western New York, that Finger Lakes region on west, we've actually had fewer reports of blooms in 2014 than we did in 2013. A little bit of an apples and orange comparison because we're not sampling exactly the same lakes all the time, but we haven't seen this explosion of blooms in western New York. Could we compare this to 1990 or 1950 or 1900? We'd love to. We just don't have that data. And unfortunately, the answer to the question, is it worse now, not necessarily 2014, but right now, contemporarily, we just don't know. We just haven't been documenting these long enough. And I hope in the near future we'll be able to get the answer to some of those questions. The other thing that you can look at, and I think this is probably a pretty good illustration, in the South Basin, you can look at 2013 compared to 2014 right in the same timeline. This plot shows an increase in algae levels as 2014 has progressed. Same thing in 2013, and they're effectively right next to each other. Open water conditions, center of the lake conditions in 2014 in the South Basin, at least so far, are almost identical to where they were in 2013. In the North Basin, which is the upper left, it's been bouncing around a little bit. Started out very low, ramped up in the beginning of July. So it was higher in 2014 in early to mid-July than it was compared to 2013. But in 2013, right around now is the time when it really started ramping up. And we'll have to see over the next couple of weeks if that's the case in 2014. So I mentioned Toledo. It's been in the news, and I just want to talk about it real briefly. For those not aware of it, in early August, there was a massive blue-green algae bloom that was detected in the western basin of Lake Erie. As a result of that bloom, and as a result of some toxin measurements that they found in treated water, the water that came out of the water treatment plant, they had to shut down the water supply for 400,000 people. But it also resulted in a shift in some domestic uses. Some workers were told to go home. Supermarkets were closed. A wide variety of responses. And the picture on the bottom left is from right within the bloom itself. This is what it looked like fairly close to where the intake is for Toledo's water supply. Why? Well, I've heard the term perfect storm, and I think it's probably a good description here. The wind pushed all of the algae that was growing in Lake Erie all in one place, all to the western basin. That's not particularly unusual. There are localized sources of nutrients that are triggering blooms, and they all, because of some significant storm events, all pushed into the lake right at the same time the wind was pushing the algae over there. Why they saw it in the water supply, and these are pictures that I just pulled offline from the intake right behind it and people sampling right next to where the intake is that the intake there is very shallow relative to other places in Lake Erie. And so could it happen here? Well, the Lake Erie intakes in the New York side of Lake Erie are in much deeper water. The intakes drop down much more. Any algae that's found there, and there's very little algae found at that depth, is intercepted in the treatment process. That's typically done in most water treatment plants, and here's just a short list of things that are done at the treatment plants. If there is a concern about toxins outside of the algae, there are other things like activated carbon that can be used as well. At this point, there doesn't seem to be as nearly the risk in eastern Lake Erie as there is in western Lake Erie. Will that change? We don't know. At this point, there doesn't seem to be evidence that we're particularly susceptible, but there is a concern. So to get back to our theme, subtraction by addition, what are the kind of things that people can do to reduce harmful algal blooms? I've mentioned phosphorus a bunch of times. Phosphorus in many lakes, maybe even most lakes, appears to be the key. So where does phosphorus come from? Septic tanks, first and foremost. It's not really the tank that we're concerned about, though we are concerned about the tank for lots of reasons related to bacteria, related to flow, but it's the leach field, because the leach field is what traps the phosphorus. It binds the soil particles within the leach field, bind the phosphorus. If that leach field is saturated, phosphorus is just going to wash right through. So one of the ways to prevent the leach field from clogging, from not being fully efficient, is to make sure that it's not overwhelmed with too much water or too much material. Keep the septic tanks pumped out. An awfully important thing that can be done. Mention storm sewers here. Pet waste. Waterfowl. Feeding waterfowl in particular can be a problem. Fertilizers, phosphorus in fertilizers was a significant issue for many years, and as many of you know, New York State passed a law a couple years ago that effectively for homeowners prevents them from being able to use phosphorus in fertilizers. Not needed. Most lawns are not phosphorus limited. They tend to be nitrogen or potassium limited. So phosphorus really isn't needed, so that we don't allow its use in the vast majority of cases. Yard waste, grass clippings, leaf litter, particularly in drainage ditches that are near the water body, all of that material can leach out phosphorus, wash right into the lake. Vegetative buffers. So critically important to intercept any of the water, any of the nutrients associated with the water, any of the soil particles associated with the water and the nutrients, uptaking those, preventing them from getting into the lake. Critically important, and I'm going to come back to that point a little bit later. So that poor shoreline buffering is usually a consequence of shoreline development, not having lawns that come right down to the shore, not having grasses, trees, shrubs that are intercepting that material. And all of these things are connected together. They all connect to too much algae in the water because these are sources of phosphorus that ultimately make their way into the lake. So that's half the talk. Now I'm going to switch gears to the other half of the talk. Invasive species. You probably heard the term. This might be a simple way of thinking about what an invasive species is. It's something that doesn't belong. It's been introduced into an environment that it's not normally found in, but it's a little bit more than that, and I'll go through that in a couple minutes. Some of the definitions are important. Native species. They're the gold standard. That's what we want. They're indigenous or naturally found in a region, and we're still debating of what the time frame is for defining what a native species is. But for now, we think of that as European settlement. In the last 500 or so years, anything that was around in North America at that point is considered native. Again, some debate about that definition. Then you have non-native species, those that don't fit that indigenous to a region at a particular time. So it's a time and a place component. So those are exotic species. There are many exotic species in North America, United States, New York, Chautauqua Lake Watershed. Many of those are not harmful, do not create an ecological problem, do not create an economic problem. Those that do are considered to be invasive species. And finally, there are a class of organisms that are native. They've been here forever, or practically forever. Sometimes they grow so aggressively, so luxuriantly, that they create problems. And that's the group that we refer to as nuisance species. To some extent, that might seem like semantics. We're just picking words out and saying, well, we're going to put this in this category and this one in this category. Some of it is based in sound ecological principles that when a non-native species is introduced into a new environment, it can grow very aggressively and can create ecological changes. Those are the ones that we're most concerned about. We call those invasive. But part of it actually is programmatic, if you will. DEC has made a determination that of all of these, invasives are the bad ones. Those are the ones we focus our attention on. Those are the ones that are being regulated. I'll talk about that in a couple minutes. Those are the ones that we provide resources for when they're available to try to manage. So you've had previous speakers talk about this, and I'm not going to go into these details. Native plants, critically important to the functioning of so many different components of an ecological community, including lakes. They are critically important. We want to have native plants as much as possible. Again, this was probably discussed by John Titus and others, and I'm not going to go into a lot of details, but there are reasons why species start invasively. And the ones that I highlighted here tend to be the primary reasons. When they're introduced, they don't have a predator. They don't have microorganisms that keep them in check. They don't have animals or other plants, in the case of plants, that keep them in check. So that they are new to a landscape and they don't have anything that prevents them from occupying more space over a long period of time. They're generalists. Most aquatic plants, and I'll spend most of my time talking about aquatic plants, have a very narrow range of conditions in which they can survive. The water gets too turbid, they don't do very well. The sediment changes, they don't do very well. The water level changes too much, they don't do very well. Invasive species can do really well in all of those circumstances. They're generalists. Doesn't matter what you give them, they'll take it. And they will often spread into an area that a native plant is choked out of because of this change of conditions. And I'll talk about how that relates to things like shoreline development a little bit later. As a result of those conditions, they monopolize light, they monopolize nutrients, and they can even produce toxins that prevent others from doing well. So, how bad is the problem? If you were to count all those dots, and I'm not asking you to do it, I did it for you. 520. 520 locations in New York State where we know that there's at least one invasive aquatic plant. About 40%, just under 40% of them have created such a problem that DEC has documented those on our priority water body list. We say they're actually affecting the way people can use those water bodies. When you ask people who live around lakes, what are the most significant problems, it's really where I started this talk, algae and weeds. And increasingly, weeds is becoming more and more of a topic of concern because of the distribution like this and the continuing spread of these invasive species. I'd say half of the calls I get are related to weed problems. That's changing. HABS is starting to overtake that, but awful lot of calls about weeds. And if you look at this distribution, the dark portion of the upper part of the map is the Adirondack Park. And an increasing number of dots there. 40% of the lakes that we know of that have invasive species in there are actively trying to manage those populations, actively are managing those populations. A much higher percentage than we see in other places, because it's a big change that's occurred there. So, part of the challenge of this process is the way invasive plants grow. And I'll just quickly take you through this plot. And again, some of you may have seen this already. When a plant first gets introduced, there's very little of it. And that occurs for a long period of time. You might have a single plant. And it takes a little while for the second plant to be there. It might need to be introduced. It might need to spread through a fragment. The seed that it's produced, or the multiple seeds, might need to move, take root, germinate, create the next layer of plants. So it might take a little bit of time for that to occur. At some point, you get a critical mass, and they rapidly start to explode. we rarely see that introduction. The plants don't say, "I'm here." By the time we see that they're here, it's usually up here, where someone says, "You know, there's an awful lot of this growing here." By then, it's very difficult to manage. So one of the goals of aquatic plant management on a statewide basis is catch them early. Intercept them if you can, but at the very least, if you can't intercept them, catch them early. And we're spending, DEC spending a large number of resources and time and effort and legal pull to address both of those things. Catching them early and trying to intercept them before they ever get there. So when they get introduced, what's the goal? What are you trying to do for a lake community from the state's perspective when we see a new infestation? And we categorize most of these into one of these groups. We might want to try to eradicate. Very difficult in most cases, but in some cases that's the goal, and I'll talk about that in a couple minutes. In some cases, we're simply trying to control it to allow the uses of the lake to continue on. Might be containment, that we might say, we can't do anything about it in here, but we want to prevent that from getting somewhere else. It might just be watching. We might say, we can't really do anything about it. We don't have any evidence that it's actually getting any worse in that water body, and it isn't worth the effort to try to remove it. It's not creating a problem. I talked a little bit about mitigation, and in some cases, not enough, frankly, but in some cases, we try to restore the environment. We try to do replantings. That much more frequently occurs on land than it does in the water, because it's a real challenge to replant in the water. But it's one of the things that we're increasingly trying to focus some attention on. So I mentioned attention. Part of the attention is trying to prevent them from getting in there in the first place. And there have been a bunch of laws, for those who have followed recently, just within the last 6 to 10 months that have been passed at a state level. Starting forward, going backwards. The most recent was the state legislature passed a law that said any watercraft that is launched from any public launching site needs to be inspected, and that inspection requires the removal of any visible plant or animal matter through washing, draining, or drying. How that's going to be enforced, how that's going to be applied, we're still working through some of those details. So the legislature has passed that legislation. The last I heard, Cuomo has not yet signed it, but the expectation is that that will occur soon. What has been signed at a statewide level is state regulations at state public launches, at least DEC launches, Parks and Rec launches, probably following fairly quickly. That's requiring an inspection and a drainage program. And then the last one that I'll talk about in a little bit more detail is a prohibited species list. Think of it as a blacklist. Those invasive plants and animals that cannot be sold, that there should be no commercial activity associated with it. And you may be thinking, doesn't that already apply? It doesn't. There are very few plants or animals that it's illegal to sell. And there should be more of them. That's what this state list was developed for. And it's close to being finalized. The agency's in the process of reviewing all the public comments for it, and they expect that the regulation associated with this list should be finalized in the very near future. So what that list looks like, think of it as the dirty dozen from the aquatic perspective. 12, actually list 13 here, the one in white in the bottom isn't technically on the list, but 12 aquatic plants in New York State that, if this regulation passes, it will be illegal to buy this in a pet store, it will be illegal to grow it in a nursery, and there will be a regulatory system, including a fine and enforcement section that's associated with it. So some of these may look familiar, some of them don't. I'm going to focus on 3 of them. You probably know this one already, Eurasian water milfoil. One of the reasons you may know it is you don't have to go very far to find it. You can find it in Chautauqua Lake, but you can find it in an awful lot of water bodies around the state. Frankly, just about everywhere in the state. I think that number is 360 locations around the state. It's a plant that's been around for about 75 years, was introduced into North America and into New York State around the same time. In New York, probably around the Finger Lakes. And there's some information on the bottom about the specific characteristics of the plant that are mostly used for identifying it. But on the right shows you a line drawing of what it looks like. It is the most abundant aquatic invasive plant in New York State. Second is the one that's been occupying most of our attention lately. Fortunately, we don't have it in very many locations. It's called hydrilla. This is a picture from Cayuga Inlet, farmer's market in Ithaca on the right, a couple of commercial boatyards on the left. If you were to position yourself from where the photographer was and look left, you'd be seeing Cayuga Lake about half a mile up. And between this picture and the lake, you would see the largest inland marina in the state, which is Alan Treman State Park. So an area where the risk of spreading it to the Finger Lakes and to the Great Lakes system is enormous. So lots of money being dedicated to try to control this, upwards of $300,000 to $400,000 a year to try to control that population. The distribution is slight in New York State. We haven't seen it in very many places. The dot on the upper left is Erie Canal, Tonawanda Creek, and Buffalo. As of 2-3 weeks ago, an aquatic herbicide treatment for a section of the canal between Buffalo and the Pendleton Lock. They effectively closed off traffic and closed the lock to allow no flow at the time when they did the treatment, again, about 3 weeks ago. They think and hope it's going to be successful, but remains to be seen as more data will show up. It's a plant that's been around the United States for about 70 years, but there are two different genetic varieties. The one that's found in the northeastern United States is a very difficult one to understand. We've only seen it in New York over the last 5 or 6 years or so. The AIS invasive plant issues in Chautauqua Lake. Eurasian water milfoil has decreased significantly, perhaps because of herbivorous insect impacts. And the plant control activities that are being proposed is a mix of controlling invasive plants and some native plants. But at least one of the focuses should be keeping these new AIS out, hydrilla and the new generation of other plants that are coming in. And in particular in those areas, I already talked about this, in those areas where there is shoreline, significant disturbances along the shoreline. I'm not going to spend a lot of time because it's been discussed by previous speakers here about the value of what we refer to as littoral habitat, the habitat in the water near the shoreline and in the riparian zone, in the area, the shoreline that's close to the water itself. Those two connect together, and an undisturbed environment in both cases create a lot of benefits and are particularly important for fish. But what relevant to this conversation, when there's a disturbed shoreline, it changes the sediment type. It can create turbid water. It can move around any plant seeds that are in there, and in some cases promote the germination of those seeds. The wave action that is not impeded anymore by this shoreline, natural shoreline, can move fragments around, and that's frequently the way plants move from one place to another. When you see that combination of circumstances, that's prime habitat for an invasive species to recolonize an area. So, the last time I was here, I talked a little bit about this study. The National Lake Assessment, on a national basis, looked at 1,000 lakes, nearly 1,000 lakes, including 12 in New York State. They did a variety of sampling along the shoreline, looking at shoreline habitat. And their finding, the major finding of the National Lake Assessment, was that a third of the lakes in the country have poor shoreline habitat and as a result have poor biological health. And it's much more likely in lakes with significant shoreline development than those that don't. And that shoreline development can take a bunch of different forms. It can be minor changes, things like removal of trees, or it can be something major, like significant retainage walls, significant artificial beaches. And I talked again about some of the impacts that those activities can have. So the lakes that are particularly susceptible to these problems, sort of summing all of these things up, poor shoreline protection, poorly functioning septic system, significantly altered physical habitat. They can contribute to blooms, they can contribute to invasive species. So I'm going to close with the 10 tips for natural lake shorelines, and I'll just read each of these out. Natural lake shores protect fish and wildlife habitat. Shoreline trees protect lake water quality. Natural lake shores keep out polluted runoff. Native plants help lake wildlife. Plant a rain garden, help your lake. Natural lake shores help prevent erosion. Perfect lawns are not perfect for your lake. Try natural landscaping. Lighten up on lawn chemicals for your lake's sake. Natural lake shores are picture perfect, and get involved. Protect your lake's natural shoreline. Thanks.